Welcome to question 8 of the 2011 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAR. For question 8 we have two events A and B, and it's such that the probability of A is 3 over 5 and the probability of B is 1/4. If A dash denotes the complement of A, calculate the probability of A dash intersecting B when, for part A, the probability of the union between A and B is 3/4. So to do this question we're going to use a probability table. So we're going to have events A and A complement, B and B complement. So the probability of A is 3/5 can be written as a common denominator with all the other probabilities as being 12 over 20. And in this probability table, 12 over 20 is going to go in this position because that represents the probability of A occurring. The probability of event B is 1/4, which can be written as 5 over 20. And in our table, we're going to put 5 over 20 here. Next up, we need to use this information to find more information to go inside the table. So we know that the probability of A union B is equal to the probability of A plus the probability of B, and then subtract the intersection probability of A intersecting B. And that formula is on your formula sheet. So that means that the probability of A union B is 3/4 can actually be written as a fraction over 20 as 15 over 20. So we're going to have 15 over 20 is equal to, and from before we know the probability of A is 12 over 20, and then we add on the probability of B, which is 5 over 20, and then we subtract away the probability of A intersecting B, and that gives us that the probability of A intersecting B must equal 2 over 20. So when we solve that equation, that's what we get, which can be put in this position in our probability table. And now the probability we're asked to find, A complement intersecting B, is this cell in the table here. And we know for a probability table that we have 2 over 20 plus the A complement intersecting B must add up to 5 on 20. Therefore, the probability of A complement intersecting B is going to equal 3 over 20. So that is what would be in that cell there. So that is the answer to part A of this question. So from the examiner's report we can see that 38% of students got that question correct, and that the examiner goes on to say a Venn diagram, or as we demonstrated previously, a probability table, would have assisted many students in answering this question. And most students tried, with varying measures of success, to utilise the relationship that the probability of A union B is equal to the probability of A plus the probability of B minus the intersection. There were a number of students who used this but wrote out the probability of A complement intersecting B when rearranging it. Arithmetic was often a weakness for some students. For part B, we're asked to still calculate the probability of A complement intersecting B, but this time for the case when A and B are mutually exclusive. So if A and B are mutually exclusive, that means that their intersection, so the probability of A intersecting B, is equal to 0, so we can put a 0 here. And that means that the probability that we're asked to find, which is this highlighted cell again, is simply going to equal 5 over 20. So therefore, the probability of A complement intersecting B is equal to 1/4. And that is our final answer to part B of this question. From the examiner's report we can see that 44% of students got that mark, and the most common incorrect response was due to students interpreting mutually exclusive as independent, which is a common error that occurs and one that you need to watch out for.